Okay, so we're supposed to complete this table for f of x equals 4 times 3 halves x. And it tells us the domain is all those numbers. Remember, the domain refers to which variable class? The x's. So this whole column over there, I'm just going to write those numbers. So that means I'm going to have -3, -2, -1, 0, 1, and 2. And basically what it means is we're just going to put in x4 and -3 over here. So I have 4 times 3 halves to the -3 power. Okay, there's two ways of simplifying this. I'll show you which way I want to show you. Let me show you one way. And this is the power rule. Everyone say power rule? In exponents, when you have it on the outside, you can distribute it to its own exponent. So class, this 3 has no exponent. What number is it? So what's -3 times 1? So I have 4 to the -3 to the -3 power. And then 2 doesn't have an exponent. What number is it? So it'll be a 1. So -3 times 1 gives you 2 to the -3rd power. And remember, how do you make 4 a fraction here? Put it over 1. So let's do that. And we just learned about negative exponents. You're going to switch places. And then you're going to take off the tag as you do that. So now I have 4. What's in the numerator now? 2 to the power of 3. And what's in the denominator? 3 to the power of 3. So class 2 to the 3rd power? 8, and 8 times 4? 32. And then 3 to the 3rd power? 7. Let's just put it in number sense. This improper fraction kind of doesn't help us understand it's between what two numbers. So 27 goes into 32. How many times? What's your remainder? Over 27, right? So my order pair is going to be -3, comma 1 over 5/27. Another way you could have done that is take this whole thing and put it into the denominator and then simplify it. It would have worked that way too. Let's try -2. 4 to the 3 over 2, and now instead of my x value being -3, it's going to be -2. Let's continue what we did before. Let's distribute the -2 to inside the fraction, inside the parentheses. What do you get, class? You tell me. 4 times what? 3 to the -2 over 2 to the -2. Class, where does 3 to the -2 go? Down. And where does 2 to the -2 go? Up. So circle it, draw arrows, super helpful. Okay, what's left in the numerator now? 4 times 2 to the 2nd, that's a 2, over 3 to the 2nd. Class, what is 2 to the 2nd?
4.
And 4 times 4 is 16. 3 squared? 8. And can you guys simplify that? 9 goes into 16 once, 7 over 9. So I have negative 2, comma, 1 7/9. Okay. Let's plug in negative 1. 4 times 3/2 to the negative 1 power. And there's a couple of ways of simplifying the exponent of negative 1. You can put all of this into a fraction over 1 and then take all of that and bring it downstairs, and you're dividing that so you have in the denominator fraction. Or you can also, we talked about just distributing the negative sign. This is called the power rule to its own exponent. So 1 times negative 1 gives you 4 times 3 to the negative 1 power and 2 to the negative 1 power. The negative exponent basically just tells you to switch. So if it's in the denominator, it goes to the numerator. If it's on the top, it goes to the bottom. It's focused, isn't it? And so now I have 4 to the, this is going upstairs, so 2 to the first power is just 2. And then going down, it's 3 to the first power, and 3 to the first power is just 3. Multiply across, and you get 8/3. Raise your hand if you got 8/3. We'll go back and convert all of those to decimals, so you get some number sense. If I put in 0, super important for exponential functions. Partner B, tell partner A something to the 0 power. Tell them. On the count of 3, class, ready? 1, 2, 3. 1. Make sure you write that. Anything to the 0 power is 1. So 4 times 1 just gives us 4. And I'm going to highlight this one in red. Class, what does 0, 4 represent when we graph this? Yeah, that is the most important order pair for exponentials, because it gives you an idea where it crosses the y-axis. Put in 1. Well, that just means there's 3/2. 3/2 times 4. Multiply across. You get 12 over 2, and 12 over 2 is? 6. 1, comma, 6. And then we put in 2, so 4 times 3/2 to the second power. That means you have 3 squared. And class 3 squared is? And 2 squared? It's really 1/2 squared, but the 2 is in the denominator. And then you can either multiply across, or you can do cross canceling, because essentially that's 36 over 4. 36 over 4 is 9. Or if you cross off your 4s, you get 9. So I got 2 comma 9. And that's it. Now, when I ask you to give me a table of values, okay, I do expect to show all this messy work. I want to know that you're not copying from the calculator. Okay, so let's put this in. A couple ways you can put this in your calculator. Let me show you old school. 4 parentheses 3/2. 3 divided by 2. And then the caret button above the division sign. You see it over here? And then you put in your x. This is one way of putting it into your calculator. The second way is you don't have to do both, but I'll prove to you why they're the same or equivalent. So 4 in parentheses, open parentheses. Everyone say alpha y equals. Really, I'm getting the F1 button, which is in a light green. So if you have a TI-83 plus, I don't think it does it. And then you could just do 3/2, press down. If you press to the right, it gives you out of the fraction. You can close it, and then to the x power. I'm going to go to my table of values to double check my numbers. So you can press second table set. You should have those on autos. So second table. Let's double check our coordinates. -3. And what's kind of nice is, do you guys see the difference between the blue and the red? What's the difference between the blue and the red? One's a decimal, one's a fraction. Now, why do I need that? For example, let's take out 8/3. I asked the student, this is called number sense, I asked the student, what is 8/3? And the student said it's a number between 3 and 8. Well, 3 goes into 8 how many times? So it's less than 3. Yes?
Yeah.
So -1 is 2.667. So when I talk about number sense, you have some kind of sense where the number lies between. 8/3 is $2.67. It's between $2 and $3. So the only reason why I like decimals is to help you with understanding of where the number is. Does that make sense? That's why they call it number sense. And why do I want you to know fractions? Because next semester is all about lots of fractions. So -3 is 1.19. Uh, 16/9 is 1.78. -2, 1.78. And then the rest we have, right? So what's kind of nice is when I graphed both the blue and the red, these look like the same functions. It gave me two different outputs. This one definitely knew it was a fraction. This one they wanted me to make it a decimal. Now if I go to graph, so zoom 6, and we expect it to be the same color. There it goes, because they're equivalent functions. And that's what our graph should look like, right? Okay, let's graph this by hand. Go down to my graph here. What I'm doing here is I'm looking at all my numbers. I'm looking at all my y coordinates. And they don't all have to be there, but maybe hopefully we have up to 9. So -3 and 1.19, $1.19, a little bit above $1. I have -2 and 1.78, so -2 and $1.78, which is more than $1.19, which is a previous problem, so it's going to go a little bit higher. -1 is going to be $2.67, $2 and some change. 0.4, which was our y-intercept. I'm going to put a red dot. 1.6, right 1, up 6, 2, 4, 6. And 2.9, right 2, up 9, 6, 8, 9. Everyone say smooth. It is smooth. It increases very quickly. And if we had more space, I'm drawing on my side of mine, it would basically be a horizontal asymptote on the x-axis. Okay? I do want to talk about some big ideas that we talked about yesterday. You have two hands, so you have two index fingers. Put each index finger, one left, one right hand, on the y-intercept. You should have one on the graph and one on the equation. Look at your partners. Give them some feedback. Shake your head yes or no. You have one here, and you have one here. Do you guys see it? Class, what are we pointing to? The y-intercept. Okay? Put your finger on the ratio, the common ratio. Class, is this number bigger than 1 or less than 1? Do you think that'll be growth or decay? Growth. And that's why the graph is going up or increasing as you go from left to right.
I love math. You don't love math? What's wrong with you?